So let us make it more interesting for you. Here we have a 3 by 3 matrix, and I ask you to find the inverse of that matrix. You have two options. The very first option is actually write AB equals to I3. I3 is identity matrix of size 3. It means that you have matrix A, you have some elements, missing elements that you need to figure out. The multiplication is equal to identity matrix of size 3. Then you can do the multiplication and come up with system of equations and solve it. Or you can apply adjoining matrix method using Gauss Jordan elimination and try to convert your matrix A into identity matrix and the identity matrix to the inverse matrix. So we form the adjoining matrix, write down the elements of A, write down the elements of I3 identity matrix, and try to convert it into this new matrix. So let us begin. My very first entry must be 1, which is below 1, I must have 0. But unfortunately, I have 1 and -6. What I'm going to do, I'm going to multiply the very first row by negative sign and add it to the second row, and this guy becomes my new second row. So -1 plus 1, 0, you get a 1. And here you have -1, you have a -1, and this is stay as 1 and 0. Very good. I'm going to multiply my first row by 6 and add it to the third row. 6 R1 plus R3 becomes my new R3. So here I have a 0. I get a -4. I have 3, and this guy becomes 6. Stays as 0 and stays as 1. So far, my first column is exactly the same as my first column here. Now let us move on to the second column. Here you need to have 1, and above and below 1, it must be 0. Unfortunately, it's not. So what I'm going to do, I'm going to add R2 to R1, and this guy becomes my new R1. So this is 0. This is just -1. This becomes 0, and this is 1, and it stays 0. I'm going to multiply the second row by 4 and add it to the third row. 4R2 plus R3 becomes my new R3. Stays 0. This is going to be 0. And -4 plus 3, -1. And 4, -4, it becomes 2. And here you have 4 times 1, 1. And 4, and here you get 4. Very good. So now let us move on to the last column here. It must be 1, which is not. I'm going to multiply my R3 by a negative sign. So this guy becomes 1. This guy becomes -2, -4, and -1. Now what I'm going to do, I'm going to make these two become 0. So I'm going to add R3 to R2 and R1. R3 plus R2 becomes my new R2. So here you have 0, you have 1, this guy becomes 0, this guy becomes, that was a -1, so here you get -3, and adding these two, you get -3, and this guy is -1. And I'm going to add the last row, R3, to R1. This guy becomes my new R1. So this is just 1, this is 0, this becomes 0, and here you have a -2, here you have a -3, and here you have a -1. So now we need to check to see if this guy is actually the inverse or not. Check. It means that you're going to multiply these two together, and it must be equals to I3. So let's write down A. A is 1, 1, -6, -1, 0, 2, and 0, -1, 3. And it's going to be multiplied by this new matrix that we created, which is -2, -3, -2, and -3, -3, -4. And here we have -1, -1, and negative. Let's see. The first row, the first column, this guy becomes, so you have a -2, so let me write down everything, -2, and then 3 and 0, this is 1. So far so good. This is my 1. The first row by the second column, -3 plus 3 plus 0 is 0. And now the first row by the last column. Here you get -1 plus 1 plus 0, which is 0. So far so good. Now let us move on to the second row. Second row multiplied by first column. You have -2 plus 0, and here you have plus 2, which is 0. Second row by the second column, you get -3 plus 0 plus 4, which is 1. Very good. Now multiplying the second row by the last column, you have -1 plus 0 plus 1, which is 0. Now we are moving on to the last row. Last row multiplied by the first column, 12 minus 6, which is 0. Then -6 times -3, 18, and -6 plus, here we have -12, sorry, -12, so this is obviously 0. And the last row by the last column, here you have -6 times -1, which is 6, and here you have -2, and then you have -3, which is 1. Very good. We ended up with I3, so this is actually the inverse of a matrix. So A inverse is equal to -2, -3, -2, -3, -3, -4, -1, -1, and -1. We found the inverse of the matrix.